For my first example on the Maclaurin series, I'm going to be using this past paper question. We're given a function g of x as x sine of x over 2, and we're asked to obtain the Maclaurin series expansion for g up to the term in x to the 4. And then afterwards, we're going to use that expansion now to find g of 2. I'm going to actually show you two methods for finding this expansion. The first method will use the formula that we saw in the previous video, which involves using derivatives. So this method requires us to be able to know how to differentiate and differentiate well. It can be tedious depending on the question. For example, this function here looks like it's going to be tedious because we have a product and we have a function of a function, which means to differentiate, we're going to have to use the product rule as well as the chain rule. So this may turn out to be a tedious question, but I'm showing you that method, and then I will show you an easier, quicker method. All right, so we start with our function, or g of x. And we're going to take it and plug in 0. Once you're doing the Maclaurin series, you're plugging in 0. When we get to Taylor series, you'll see that we'll be plugging in depending on the x value that is given. But once it's the Maclaurin series, we're plugging in 0. If you plug 0 into that function, you're going to get 0. Then we take the first derivative. So we're going to be differentiating g using the product and the chain rule. Product rule, differentiate the first, we get 1, keep the second. Plus, other way around now, we keep the first, differentiate the second. To differentiate sine of x over 2 or sine of half x, we're going to use the chain rule. So we differentiate the inner function, that gives me half, and then differentiate the outer function. So we're going to have half cos of x over 2. Let's just simplify this a little bit. And then we're going to take this now and plug in 0 for x. So we're going to have g prime 0, which this term is going to give me 0, and this is also going to give me 0 because of this x here. So we're going to get 0. Now we're going to find the second derivative. Differentiating this, we're going to use the chain rule. We're going to get half cos of x over 2. For the next one, we're going to need the product rule. Differentiate the first, keep the second. So that's going to be half cos of x over 2. Plus, the other way around now, we're going to keep the first while we differentiate the second. So that's going to be half x times, remember chain rule for this, will give us negative half sine of x over 2. So keep the first, which is a half x, times, differentiate the cos. You know, when you differentiate cos, you get negative sign. So we're actually going to get negative half sine of the x over 2 because of the chain rule. See if we can simplify this. These two are like terms. So half plus half, that's 1. So that gives me cos of x over 2. And then this is going to give me negative a quarter x sine of x over 2. And then remember, we now need to plug in our 0 for the x. So g double prime 0, if I plug that in here, I'm going to get 1 because cos of 0 is 1. I'm going to get 1 here, 0 there, so I get 1. Third derivative. So you see, this can be tedious and you have to be good with differentiation when you're doing the Maclaurin series. Differentiating this using the chain rule, we're going to get negative half sine of x over 2. Differentiating this, we're going to need the product rule. I'm actually going to keep the negative quarter on the outside as a constant, so keep my constant. And then use the product rule on the x sine of x over 2. So differentiate the first times the second plus keep the first, differentiate the second. Let's see if we can simplify this. We have two like terms here. Negative half minus a quarter, that's going to give me minus 3/4 sine of x over 2. And then this term distributing the negative quarter is going to give me negative 1/8 x cos of x over 2. And now I'm going to go ahead and plug in my x as 0. If I plug 0 here, I get 0. If I plug 0 in this term, I get 0 again. So g triple prime 0 gives me 0. Now we're going to do the fourth and last derivative because we're going up to the x to the fourth term, which means we need to go up and not beyond the fourth derivative. So we're going to differentiate this. That is going to give me, using the chain rule, negative 3/8 cos of x over 2. Because we differentiate this, we get half times this. Differentiate the sign, we get cos. For this, I'm going to use the product rule. Again, I'm going to keep the constant on the outside and use the product rule on the x cos of x over 2. So differentiate the first times the second plus other way around, keep the first times differentiate the second using the chain rule. And we can go ahead and simplify. This is negative 3/8 minus 1/8 cos of x over 2. That's going to give me negative 4/8, negative a half. And then this, when I distribute, will become plus 2/8 16. So 1 over 16 x sine of x over 2. And then, of course, I'm going to plug in 0 for x. This is going to give me negative half. And this gives me 0. So the result there is negative half. Let's use those derivatives now to plug into the formula to generate our function. Therefore, my g of x, which is x sine of x over 2, according to the Maclaurin series, let's look back at the Maclaurin series. This is what we're going to be using. It is equal to, in this case, g of 0, which we had gotten g of 0 to be 0. I'm going to write it down just for teaching purposes. Plus, the next term is x over 1 times g prime 0. So x over 1 times, and the g prime 0 was also 0. Plus, going back to the formula, x squared over 2 times the second derivative of 0 now. So x squared over 2 times, let's look for our second derivative. We had gotten 1 plus, and we should be seeing the pattern by now. It's going to be x cubed over 3 factorial times the g triple prime of 0. So the third derivative with 0 plugged in, which had given us 0. And then finally, the x to the 4 over 4 factorial, which is 24, times that fourth derivative that we had gotten to be negative half. So this is going to give me, first term is 0, so we get rid of that. This is 0 also. This is half x squared. This is going to be 0, so no x cubed term either. And then finally, this term is going to be minus 1 over 48 x to the 4. So that's the Maclaurin series expansion for this function. I'm going to go ahead and do method 2 to show you before I move to part 2 of the question. I'm going to do method 2 to show you a quicker a quicker way that you could have worked this particular question. But you must know to use the Maclaurin series expansion formula. You must know to use it, because the method I'm going to show you is based on you having this table. Based on you having this table in the exam. If you get another function that is not any of these, then you will be in trouble if you don't know how to use this. Because the method I'm going to show, the quicker method, actually uses the table, right? If we have e to the x, we have ln of 1 plus x, ln of 1 minus x, we have sine x, we have cos x. So if we have anything like those in the question that we're given, we can use these. But if we get some other function that is not here, then we must use the formula, right? So we can't say we're not going to learn the formula because we're going to do the easy method or the quick method. We must know the formula. All right, so for method number 2, I'm going to put it in a different color. What I have here, let's look back at the question. What I have here is two functions multiplying each other. We have x, which is already a polynomial. Remember, our aim with the Maclaurin series is to rewrite our function as a polynomial. X itself is already a polynomial. We're going to rewrite sine of x. In this method, we're going to rewrite sine of x over 2 as a polynomial. So we're going to do this, not the entire function. We're going to take this piece only, the sine of x over 2, and we're going to generate its Maclaurin series expansion from the table that we're given in the exam, right? From the formula sheet. So sine of x over 2, according to the Maclaurin series, let's look back at the formula sheet. The expansion you're given is for sine x. But because we want sine of x over 2, we're going to replace these x's with x over 2. Again, because the expansion is for x, but we want it for x over 2, we're going to replace x with x over 2. We're only going to go up to this term. We don't need to go beyond this term because the question had said up to the x to the 4th term. So we wouldn't have gotten to the x to the 5. So we're only going to involve these two. So we're going to have, replacing this x with x over 2 minus, then we're going to have this x replaced with x over 2. So we're going to have x over 2 cubed. And that is going to be over 3 factorial. And this is going to give me half x minus x over 8 divided by 6, 1 over 48 x cubed. So the Maclaurin series expansion for sine of x over 2 is this. And this is taken from the table. All right, this is from the table of the table given in the formula sheet. So that's how we obtain this. Now, because we want x sine of x over 2, this is already a polynomial. We're going to replace this with its polynomial series, or the Maclaurin series to be more specific. So this is x times half x minus 1 over 48 x cubed. And if I expand that, I get half x squared minus 1 over 48 x to the 4. The same thing I got earlier, except that this is much quicker. And the table was provided by CXC, which means you're free to use the table. So we just used the table and we were able to get the same answer like we did using derivatives, which took us much longer to do. Now, as I said, you must know to use the formula. You must know how to do it using the derivatives. You may get a function that is not in your table, or you may be required to derive the formula, and so on. So it's important that you know how to use the formula like I did in method number 1. Right? So method number 2, you can use it if you even have, let's say you had 2 functions being combined from the table. So this one, we had a polynomial being combined with something that we could have used from the table. Let's say you had, for example, they had combined an e to the x with a sine of something, or a cos, or whatever the case might be. You would choose what you need from the e to the x up to whatever term is required, times, same thing, choose what you need from the sine x, right, up to whatever x is required, and then multiply them. Obviously, if it's division, you won't be able to do it that way. So for example, if it were e to the x over sine x, and you were to take this piece and divide it, for example, by this piece, it would not have been so straightforward. It would have been easier to probably do the differentiation, method number 1, right? So it depends. You have to assess the question and determine the best approach. Going back to part 2 of the question, it says, hence estimate g of 2. So now we know what g of x is as a polynomial, as the Maclaurin series. All we're going to do now is to plug in x as 2 to find g of 2. So g of 2, if we look back at our screen, this is our g of x. So we're going to plug 2 in. So it's going to be half times 2 squared minus 1 over 48, 2 to the fourth. And that gives me 5 over 3.